In this video, I'll be using the Zetec Miz-21C and a surface plus point coil. That's just the detachable tip in the end there. Kind of looks like a T, but some of the paint's wore off there. You can see it's actually a plus. So this is a differential coil arrangement, and it has opposite polarity for different directional flaws. So axial flaws will have one polarity, and transverse or circumferential flaws will have the opposite polarity. The cowl block I'm going to use is 304 stainless. It's got EDM notches ranging from 10 mils deep to 80 mils deep. And all I'm going to do is scan along my block like so. Now, pay attention to the impedance point as I bring the coil down to my test material. And when I go off, it goes the opposite direction. That's because it's a differential arrangement. Now I'm just going to scan down the block. I'm going to start with the shallowest first. Oh, I got my alarm set. I guess I was going with the deepest first, huh? Yeah, I went with the deepest ones first. So there's shallow, next deepest, next deepest, next deepest. Next one's going to set the alarm off. There we go. And the deepest one's right there. Now if I rotate my plus point probe head 90 degrees, you'll see that they all go in the opposite direction. And actually this is the same type of plus point coil that they use in rotating probe heads like this one. So in this rotating probe head here, you have a plus point coil, very similar to the one that's in my weld probe. Then 120 degrees away, there's 115 mil diameter pancake. And then to confirm ID flaws, you have a smaller 80 thousandths diameter pancake coil. So this just attaches to a motor unit that spins through a tube or any other type of open hole, I guess. But today we're focusing on the surface routing plus point. So again, one more pass along my cowl block. And now I'm going to go to this sample plate. And what I'm going to do first is I'm going to position my probe like this. I'm just going to scan along this way. And I'm going to do that on both sides of the weld. There's the first pass. Now you may notice that my impedance point's not moving a lot. The only filter I'm using right now is a continual null filter. So that just keeps my impedance point fairly steady in the center of my screen. Now I'm just rotating the weld plate 180 degrees. And I'm going to go up to the weld again. I'm going to scan along the weld. And again, this is the back of the weld. So now I'm going to go along the front. And I'm just going to go down the side like this, starting to scan. If I get too close to the edge, it'll go off. See that? I'm just going to scan it down along the plate. Now I'm turning the plate 180. There we got something. So again, I just wanted to use the surface routing plus point first before I switch over to the array. And so here it looks like we have some sort of axial surface breaking, axial crack along the side of the weld. I'm going to go to the other side. And I got nothing. So it's pretty easy to find where this is. It's right... Nope. It's right there. See it? Anyway, that's just a quick example of using a plus point differential arrangement weld probe on 304 stainless.